Alan from 2620 is active. If you like my videos, please comment and share, and if you are new to the channel, don't forget to subscribe. Today we will discuss on operators in Java. So Java is rich in operators, and we will discuss the most common and important ones, and operators which are important in some other paradigm or concepts of Java programming will be included in those sections. The commonest operators that are used during programming are the arithmetic operators, and these are the basic mathematical operators that we know from our elementary school. And the other operators are bitwise operators. When we say bitwise operators, as we have discussed in our introduction to programming, memory is organized as switches of circuits represented as zeros and ones, and bitwise operators operate on those bits. And the other is relational operators, and these are operators with an output of Boolean type. As we have discussed Boolean type in our data type section, it's a data type with two values of either false or true. The other operators in Java are logical operators. We will have, as I have said, we will have other operators like ternary operator and instance of operator and so on. We will see them on their respective sections, but these are the basic operators that we will discuss in this section. So basic arithmetic operations. The first one is addition. So addition is the operator where we add two numbers together to come up with a result, and in Java we use addition in the usual mathematical type operation, as well as there are special semantics used in Java as well. But the plus operator in strings has got a different meaning, and we will discuss that one in the section about strings. So if we see an example, let's declare a variable a of int type with a value of 5 and b with a value of 6, and an int with identifier of c, and the basic mathematical operation used in addition is adding a and b and assigning that value to c. So this is the use of addition in adding two numbers, but we use addition as well in assignments and in other semantics. For example, here it says a is equal to a plus 4. So this means take the value of a, which is 5 here, and add 4 and assign this back to a. So this will make the value of a 9. Okay, so in mathematics this kind of statement will not have a meaning, because it will result in a statement of a is equals to 4, which is 4. So in Java it means add 4 on the value of a and assign the result to a. Okay, so this is one of the different semantic use in Java, syntactic use. And the other is, this is similar as this one. This is called sometimes compound assignment operator or augmented assignment. So the equal to sign is an assignment sign. That means it assigns a value to a variable or any other variable to another value. So this is called augmented assignment, and this adds 4 on the value of a and assign it back to a. So this and this one has got the same meaning. Okay, so this is very critical to look into when we work with, particularly in loops and short circuit additions. The other is subtraction. It is the same as addition, so we use these same values and we assign the difference of a and b to c. So that is the usual mathematical use of subtraction, and like we have used the addition operator to subtract a value from a variable and assign it back to that variable, we can use this one. So previously we used adding integral literal, that means 4 on a variable. Now we can do the same operation with variables. So we have got a variable and c a variable. So when we subtract a from c and assign it back to c, this is using subtraction in different syntactic style in Java. The other is the augmented assignment of the subtraction, and we subtract a from c and assign it back to c. So this one and this one are similar statements, similar outcomes. We have similar outcomes. Multiplication will also have the same approach. Multiplication is effected through symbol of star, and if we do here the same mathematical operation, we will get the result of the product of a and b, and here we will multiply c and by a and assign it back to c. So here this is the augmented multiplication assignment. So here you will see c multiply is equal to a, and this means multiply c by a and then assign it back to c. And division will also have the same application. You will divide a and by b and assign it to c, and you can assign the division of c by itself and back to c. So you divide c by itself and then assign it back to c, the result. So this one is the same as this one, augmented assignment. The other operator in Java is modulo, which is effected through the percent sign, and modulo operator outputs the remainder of a division. And to look into an example, let's have an integer a 15, b 6, and c. So if we assign a modulo b to c, the value of c will be 3. So as you divide 15 by 6, when it's integer division, you will have a result of 2 and 3 remainder. So the modulo operator will bring assign the output of 3 to c. And modulo operator is also used like the other operators. The modulo of c to b can be assigned back to c, and the augmented assignment also works for the modulo operator as well. So c modulo is equals to b means c is equals to c modulo b, like this one, and it assigns the modulo or the remainder of c to b back to c. So here we have 3. say 3 modulo b means 3 divided by 6 remainder. So that means 3 divided by 6 is 0, the remainder is 3, so 3 will be assigned here. The same works here. The other important operators in Java used as with the addition operator in a different style, and the subtraction operator in a different style is increment and decrement operators. So when we say increment, we use the addition sign twice, and we can put this operator, the plus plus operator, after the variable or before the variable. Pre-post means that one. We can put it before the variable or after the variable, and it increases the variable by 1, but it has different outcome. So let's say we have a variable called x with a value of 0. Then if we put the increment operator before x and execute it, it increases x by 1. So if we do with the post one, it does the same. Okay, the difference will be if we assign increased value of x to some other variable. So if we do it with the pre-increment operator, the value of x will be increased before it is assigned to another variable. But if it is a post, the value of x will be assigned to the variable, and the increment will happen after that. Okay, so here int y is equals to plus plus x means increase x by 1 and then assign the value to y. Here int y is equals to x plus plus means, okay, assign x to y and then increase the value of x. So this is the difference of the pre increment and the post increment. And the other one is decrement. This is 2 subtractions in sequence, so they apply the same thing. Okay, so here it decreases x by 1, and if you assign the decrement operator to value and assign it to another variable, so if it is pre-decrement, that means before the variable, then it will decrease the value of the variable and assign it to the left side variable. If it is post, then the decrement will happen later on. So this will decrease the value of x and assign it after decrement to y. This one will assign the value of x to y and then decrease the value. So bitwise operators. We have got several bitwise operators, and the first one is the not operator. So this is unary operator because it acts on a single variable or a single value. So for example, we give it a sequence of bits, it will invert that value. Okay, so here you can see if we have a variable called a, and if we give it the value of 0, not a results in 1, and if the value is 1, not a results in 0. Okay, and if we do, for example, not 0011001, we will get the result as 0 will be 1, the next one will be 1, and the 1 ones will be converted to 00, and so on. So it inverts those bits. It's very important operator in bit operations. The other is bitwise AND. So this produces an output of the result of the operation of 2 bits with an end. So it acts on 2 values. That's why it's called binary operator. And in the case of bitwise AND operator, if both bits or one of the bits is 0, then the result is 0. The result will be 1 only when both of the operands are 1. So here we have got a variable a, variable b, and if both or either of them is 0, then the result a and b is 0. It will be 1 only if both are 1. So if we end a sequence of bit data like this, so the result will be 0, 1, 0, 1 and 1 will be 1, like that. All will be ended and the result will be produced. That's how the bitwise AND operator does its work. So the other is bitwise OR, and this one also acts on 2 values. That's why it's binary bitwise operator, and the result will be 1 if both of the variables are 1, or either of the variables is 1, we will have a result of 1. Okay, if both bits are 0, then we will get 0. So the same table as the previous one, but with OR operator. So if both variables have a value of 0, then we will get 0. If either of them is 0 and the other is 1, then we will get 1. If both are 1, obviously we will get 1. So when you OR 2 values with a sequence, so if both are 0, you will get 0, otherwise you will get 1. So the other is exclusive OR, and this means that it operates on bits so that either of them must be 1, okay, to have a result of 1. If both are 0 or 1 or the same, then the result will be 0. So this means if both are 0 or 1, the result will be 0. So if either of them are 1, then the result will be 1. And exclusive OR is very, very important in arithmetic operations of the CPU with addition of bits is operated or effected through exclusive OR, and this is very important operator in bitwise operations. So if we have this and this exclusive OR, sorry, here the operator is OR, it should be the exclusive OR, the result will be this one, okay, 1 0 1 0 1 0. The other bitwise operator is shift right. So as the word indicates, it shifts bits to the right, okay. So it is effected through the 2 operators connected by the shift right operator, and one of the operands is binary number, the other will be an integer. So the binary number will be shifted to the right by the specified integer number, okay. So for example, if we have this one, it means shift the bits to the right. So we will have when we shift this one, we will drop the first 1 and 0, and we will have this one, okay. So to add in place of these shifted values, with 0, we'll use another operator called shift to the right with fill zeros. Okay, so that one is effected through 3 greater than signs, and here it will shift the bits to the right by 2 values, and it fills the zeros, the empty spaces from the left side when the values are shifted by 0. In the previous operation, there is no filling of the empty spaces. When you shift the values, you will use the shift with fill 0. Okay. The other one is left shift, and it works as the right shift, but it shifts the values to the left. So if we have this value, we will shift the values twice, and we will remove these 2 zeros in the left side, and then the empty spaces will be filled with 0. Okay. The other operators that are very important in Java are relational operators, and these operators are very important in control statements, the conditional and loop statements. We will discuss them in their section, but we will see the operators here. Okay, so always the relational operator produces a Boolean value. So this one is the equal to sign. Okay, as we have said, a single equal sign is assignment operator. It assigns a value from the right side to the left side. Here, this is an equality sign. For example, if we say 7 is equals to 7, the outcome is true. Okay. The other one is not equal to, and for example, this one will produce a false result. Here we have got greater than, these are elementaries, and less than. The other one is greater than or equal to. So here we will use the greater than and 1 equal sign, and this statement, for example, produces a true Boolean value because it is saying greater than or equal to, and when you connect 2 7 values, the result will be true. And the other is less than or equal to, and it operates like the greater than or equals to, and it uses less than sign and then 1 equal sign. Other group of operators in Java are logical operators, and somehow the symboling of logical operators is similar with some of the symbols in bitwise operators, and the outcome of logical operators is a Boolean value like that of relational operators, but you have to be very sure that when you use those symbols, you have to be very sure where you are applying them. So when you apply them to bits, they will be bitwise operators, and when you apply them to Boolean values, they will be logical operators unless you use specific ones. So the first logical operator in Java is AND, and it's represented by the ampersand, and you apply it in between Boolean values. So true and true results in true. So this true value can be stated as it is true, or a relational operators with a Boolean outcome, and this one can be a value true or a relational operator with a Boolean outcome. So we use the double ampersand symbol for short circuiting. When we say short circuiting, it means that the expression evaluates the result of the first one, Okay, so if it evaluates the first one and comes to be false, then the evaluation of the expression will halt there, because whatever the outcome of the second argument, the result is always false, as the AND operator requires both operands to be true to have a true result. So it stops there and continues the execution. So that's why we use the short circuiting, and it's good to use the double ampersand for logical purposes, so that it will be easier for the programmer to identify from bitwise operators. But the point is, you have to identify where you are using the operator. The other is the logical OR operator, and it is represented by the vertical bar sign, and it takes two Boolean values or two values with expressions with Boolean outcomes are also possible. Like that of the AND operator, it has a short circuit operand, which is a double vertical bar, and this works at the short circuit AND operator. So if the first operand of the OR operator, the double bar OR operator, is true, then it will execute the statement within that condition or loop, because whatever the result of the second argument, the result will be true, so it will continue on executing the statement within that condition or loop. The other is logical exclusive OR or XOR, and it's represented by the this sign, and it is similar with the exclusive OR of bitwise operator, so you have to be very, very observant in avoiding mistakes. So it takes two values, so if both values are either true or false, if both values are true or false, then the outcome will be false. Otherwise, if either of them is false and one of them is true, the outcome will be true. There is logical NOT. As you remember, we have a unary NOT operator for bitwise operators. Here we have a logical NOT, and it's represented by exclamation mark, and it inverts the Boolean value it's provided. If it's false, the outcome will be true. If it's true, the outcome will be false. Like the other operators, logical operators have got augmented assignment versions. So for example, AND has got ampersand equal to, and this means that if you take a Boolean variable f and use AND ampersand, it means that evaluate the logical end of f and the true, and assign that value to the variable f. Okay, so it has got augmented version 2, or logical or also has got augmented version, and likewise it is indicating that evaluate the OR value of f and true, and whatever the outcome is, assign it to the variable f. And exclusive OR also has got augmented version, and exclusively OR with true the variable f, and assign the outcome to the variable f. Actually, the NOT operator, when it is combined with equal to sign like that of the augmentation, it is read as not equal to. Okay, f not equal to true, and this is evaluated as a Boolean expression. The other important concept that you have to understand and always consider is operator precedence. So we have got the highest precedence for increment operator and decrement operators, the pre more than the and the post more than the pre, and it's followed by the multiplication, division, and modulo signs, and then addition, subtraction, and right shift, left shift, greater relational operators, equality operators, and exclusive or and or, and then the short circuit and short circuit or. This one is called the ternary operator, and these operators, this is assignment operator. This one is lambda operator. It is referred to as becomes and used in lambda expressions, and we will discuss it when we reach to the section where we will discuss lambda expressions in Java. And make sure that you use your expressions considering the precedence, or use brackets to avoid confusion. So as you know, expressions within brackets are evaluated first before other expressions, and they will be included in your evaluation. So if you have any concern, actually it's advised that you use brackets to make sure or clear which expressions should be evaluated first and then what. So you have to do that one. That's it for this video. Thank you for your time.